We are now going to clear equations of decimals and fractions. Because a lot of times students will see an equation like the following: y plus 1 over 4 plus y minus 2 over 10 equals y plus 7 over 20. And when they see this, they panic a little bit because the fractions are in the way, and it's not as easy to add numbers and to add that are fractions together, subtract or multiply or divide. And so the goal is to remove the fractions or the decimals from the problem so that they become easier to solve. And the way we do this is we find our lowest common denominator, which is the smallest number that every other denominator divides into. So the smallest number that 4 divides into, that 10 divides into, and that 20 divides into. And there's several ways to do this, but my preferred method is to look for prime factorization. So 4 is 2 squared. 10 is 2 times 5, and both of those are the first part. There's only 1 2 and 1 5. And 20 is 2 squared times 5, because that's 2 times 2 is 4, 4 times 5 is 20. And our lowest common denominator needs at least as many copies as the largest number of copies that every prime number has. So our LCD needs at least one of each base, so it needs at least a 2 and a 5, and this is also the first. But then we pick the highest power that shows up, so that 2 squared, because we have a square here and a square here, and 5 to the first, because that's our highest power on the 5. We don't need any 3s or 7s or 11s or anything else like that. We just need 2s and 5s, and 2 squared is enough because the 4 divides into it, and the 4 from the 20 divides into it, as well as the 2 from the 10. Those will all divide evenly into 2 squared. Then we multiply this out, and we'll notice that in this case, our LCD is in fact one of the numbers, 20. So now we get into the problem itself, and we multiply both sides by 20 over 1. And we're going to distribute. So now I get 20 over 1 times y plus 1 over 4 plus 20 over 1 times y minus 2 over 10 equals y plus 7 over 20 times 20 over 1. Remember, multiplication is associative, so the order doesn't matter a whole lot. But now we can divide out our fractions. 20 divided by 4 is 5. 20 divided by 10 is 2. And 20 divided by 20 is 1. So we're left with this 5 on the outside times what was on top, y plus 1, plus 2 times what was on top, y minus 2, equals 1 times y plus 7. And now we are ready to solve this problem as if it was any of the other ones that we've seen earlier. So we can start by distributing 5y plus 5 plus 2y minus 4 equals y plus 7. Now we combine like terms. 5y plus 2y is 7y. 5 minus 4 is plus 1. Y plus 7. We will now subtract a y from each side, so we move all our y's to the left, and we'll subtract 1 to get our constants on the right. 7y minus y is 6y. 1 minus 1 goes away. Y minus 1, y goes away, and 7 minus 1 becomes a 6. Divide both sides by 6, and we get our answer of y equals 1. Well, does this work? Let's go back to our original and let's find out. So we plug a 1 in. We get 1 plus 1 over 4 plus 1 minus 2 over 10. Does that equal 1 plus 7 over 20? Well, 1 plus 1 over 4 is 2 over 4 minus 1 over 10. Does that equal 8 over 20? So now we need to play the fraction game and add and subtract, and it's going to be easy. If we look here, we can see that this 20 is going to reduce but the 1 over 10 and the 2 over 4 not. So let's just leave everything in terms of 20 and see what comes out. So the 2 over 4 is missing 5 to get up to 20, and the 10 is missing 2. So 5 times 2 is 10 over 20 minus 2 over 20. Does that equal 8 over 20? Well, 10 minus 2 is 8. Does 8 over 20 equal 8 over 20? Sure enough, it does. So our answer is, in fact, y equals 1. So the point here is that by finding the lowest common denominator, 20, we were able to multiply both sides by it to clear out the fraction, so we're only left with whole numbers that are easier to manipulate and distribute and use. And notice the reason we wanted 20, we could have used 40, because 4, 10, and 20 all go into 40. Could have used 60, could have used 80, but they would have generated bigger numbers here that are left over after we divided. And we want to keep our numbers as small as possible so that they're easier to use and easier to get through and work with. Alright, let's now look at decimals. So suppose we had the problem 0.07x minus 1.3 equals 0.05x minus 1.1. Now decimals are easier than fractions in a lot of ways, and one of those ways is when we want to remove decimals, the easiest way to do that is to multiply by enough tens so that the decimals move, because every time we multiply a decimal by 10, the decimal point moves one spot to the right, making the number bigger. And so we're going to look at all of our decimals. We've got 1, 2 spots here, 1 here, 2, and 1. So it looks like I have 2 decimal places to be moved. So that's going to be multiplying by 10 to the second power, or 100. So let's multiply this side by 100, multiply this side by 100. Let's see what happens. So we distribute. So we get 100 times 0.07x minus 100 times 1.3, 100 times 0.05x minus 100 times 1.1. And I'm using that commutative property to move the 100 to the front, even though I wrote it on the back originally. So now when we multiply this, 100 times 0.07x becomes 7x. 100 times 1.3, because we move 1, 2. Move 1, 2. Oh, that becomes 130. Equals 5x minus 110, because again we move 1, 2, 1, 2. And we're back to whole numbers, no decimal points floating around. So count the number of decimal points, and that's the number of zeros you need to multiply by following that lead 1. Solve it like any other problem. Let's subtract 5x now, add 130, and we get 7x minus 5x is 2x, minus 130 plus 130 is 0, 5x minus 5x is 0, minus 110 plus 130 is 20. Divide both sides by 2, get x equals 10, and there we are, ready to run. X equals 10. Looks like that's our answer. Let's find out. Is 0.07 times 10 minus 1.3 the same as 0.05 times 10 minus 1.1? Well, multiplying by 10 just moves our decimals. So we have 0.7 minus 1.3 equals 0.5 minus 1.1. Remember, we should be putting question marks because we're not sure this works yet. 0.7 minus 1.3 is the same as 1.3 minus 0.7 with a negative sign. So that's going to be minus 0.6. Do the same thing on the other side. 0.5 minus 1.1 is the same as 1.1 minus 0.5 with a minus sign. And so we also get 0.6. Notice both sides are in fact the same, so that checks out. So this is our answer. So by moving the decimal place out of the way, by clearing the fraction with the lowest common denominator, we put the problem back to a form we know and love, and then can solve from there.